In this video, I'm going to review acids and bases as well as equilibrium in general. This is something you did a lot in general chemistry, so if you do need to brush up on this, I suggest you go back to your general chemistry notes. I also do think that the worksheet goes over this fairly well, especially the calculations. So check that out, and if you have any questions about how to do the calculations, please let me know, but I'm not going to go over any of those calculations in this video. So just to review equilibrium chemistry, as we know, many reactions are reversible. For example, acid-base reactions, meaning they can go both in the forward direction and in the reverse direction simultaneously. And to indicate a reversible reaction, we use double arrows rather than a single arrow, as we would for a reaction that would only go in one direction. So the reaction in the box is an acid-base reaction, and it shows this molecule as the acid because we have this hydrogen being ionized or donated, and if the acid is on the left, then this must be the base on the right. And the box below shows the progress of a reaction from a reaction starting with only reactants to reaching a state of equilibrium. So here we would have a certain amount of reactants, and at the beginning we don't have any products, but over time the reaction proceeds such as some of the reactants are used up and products are produced. And then at some point in time after that dashed line, we reach a situation where the concentrations of products and reactants are no longer changing, and that means we're at equilibrium. But also remember, equilibrium is a dynamic process, which means that even though the concentrations of reactants and products are not changing, the reaction is still proceeding forward, and it is also still proceeding in the reverse direction. So another way to talk about equilibrium is to say that the rate of the forward reaction is equal to the rate of the reverse reaction. So again, these reactions are still going on, just as some reactants are turned into products, an equal number of products are turned back into reactants. So when we talk about acids and bases, we usually talk about a Bronsted-Lowry acid and base. So that means we're talking about where the protons go, or where the H pluses go. An acid is something that donates a proton, and a base is something that accepts a proton. And when we're talking about acids and bases, we can talk about strong acids and bases, and we can talk about weak acids and bases. Remember, strong acids ionize completely, so that means we have a single arrow, which means that that is only a one-way reaction. It does not occur in the reverse direction. So HCl will completely ionize to produce H plus and Cl minus. Weak acids and bases, on the other hand, only partially ionize. So these are equilibrium reactions, so we have the double arrow. So this reaction would produce some NH3 and some H plus, but there would still be a fair amount of NH4 plus present in a reaction mixture. Now we can also talk about a salt being acidic or basic. So remember, salts, when they dissolve in water, they ionize completely. So an example of ammonium chloride as a solid, so that's a salt. When it dissolves in water, it produces NH4 plus and Cl minus. Now, to determine whether or not this salt is acidic or basic, we have to know whether the products of the reaction, the NH4 plus and the Cl minus in this case, will react with water to produce either H3O plus or OH minus. So if one of these products donates a proton to water, that would produce H3O plus, which would make it an acidic solution. If one of these products accepts a proton from water, that would make OH minus and result in a basic solution. So hopefully you know that the NH4 is the one that's going to react with water. It's going to donate a proton to water. So we're going to have NH4 plus going to NH3 plus H3O plus. So because the H3O plus is produced, we have an acid. And Cl minus is not going to react with water. If you remember up here, Cl minus cannot grab an H plus and produce HCl because that's a one-way reaction. Okay, so Cl is just a spectator ion. It's not going to do anything. So here's a graphical representation of a strong acid ionizing in solution. It's the same picture for a strong base. So in this case we have nitric acid, HNO3. That's the acid. It's dissolving in water, H2O. So there is the base in this particular example. So if we had 0.1 molar nitric acid at the beginning of our reaction, in the end, we don't have any nitric acid and we only have its ions in solution because nitric acid is a strong acid and it ionizes completely. So here are some common strong acids and bases that you learned about in general chemistry. These are ones that you should know and you should memorize, because when you're given an acid or base in a question, you will have to know whether or not it's strong acid or a strong base or a weak acid or a weak base, because the calculation involved is going to be different depending on whether it's a strong or weak acid or base. So memorize the strong acids and bases, then you know anything else that you're given is going to be a weak acid or base. So to help you memorize the strong bases and strong acids, you can look at a periodic table and just see where they're located. So on the left-hand side of the periodic table, we have lithium, sodium, potassium, rubidium, cesium. Those hydroxides are strong bases. And on the right-hand side of the periodic table, the easy ones to remember anyway, HCl, HBr, and HI. Now there are also a few more strong acids that you should remember, and those are on the previous slide. So we have sulfuric acid, nitric acid, and perchloric acid. Now another thing you looked at besides acids and bases in general chemistry were precipitation reactions. So in this case you were talking about KSP, or the solubility product. So we would be worried about this if we would start with two soluble salts, and then what happens when they dissolve, they react to create something that is insoluble. So for example, if we had lead nitrate and sodium chloride, both of those are soluble, but if we mix them together in the same solution, the lead chloride ends up forming a salt. So it's an insoluble salt, which means not very much of it dissolves. It does create some ions, lead 2 plus and chloride minus, so a little bit dissolves, but not much of it does. And if you remember, the KSP is going to include only aqueous products and not the solid. So when we're talking about equilibrium expressions, remember it's the concentration of products divided by the concentrations of reactants. Lead chloride as a solid is not included in that equilibrium expression, so our KSP expression ends up being the concentration of lead 2 plus times the concentration of Cl minus squared. And remember, because we have a 2 here, that 2 ends up going down there in the equilibrium expression. And the number that we get out of it, the 1.7 times 10 to the minus 5, tells us whether or not the reaction is reactant favored or product favored. If this is a number that is much less than 1, which it is, then this is a reactant favored equilibrium, meaning there's going to be a whole lot of lead chloride solid in this mixture and very little lead 2 plus and Cl minus dissolved. So remember, a value of less than 1 indicates a reactant-favored reaction for any equilibrium constant. And for a KSP expression, they're always going to be less than 1 because we're talking about something that is not very soluble. If we have an equilibrium constant that is much greater than 1, then that's a product-favored reaction. So we would have lots of products at equilibrium and not very many reactants. Again, remember these reactions are at equilibrium, so we still have that reaction going on. There is some lead chloride dissolving to lead 2 plus ions and Cl minus ions, but some of the lead 2 plus ions and Cl minus ions are also recombining to precipitate into the lead chloride salt. Now we talked about strong acids previously, so now let's talk about weak acids. So again, weak acids only partially ionize to give H plus and a conjugate base. A weak base will only partially ionize to give you OH minus and the conjugate acid. We could write it as a general chemical equation, just like this. So HA meaning a weak acid, reacting with water to produce H3O plus and the conjugate base. A minus is the conjugate base. Or if we want to shorthand it and forget about the water, if we take off water from both sides of that reaction, we end up with HA producing H plus and A minus. And the equilibrium expression for that, again, Same as any other equilibrium expression, the concentration of products over the concentrations of reactants. So it's going to look like this. Weak bases is similar. So we have a base plus water producing the conjugate acid and OH minus. And again, we're not going to include water in this equilibrium expression because water is a pure liquid, and just like solids, they're not included in equilibrium expressions. So here's a graphical representation of how a weak acid would dissolve in water. So in this case, we have nitrous acid, HNO2, reacting with water. So this is the acid, water again is the base, and it's producing NO2 minus ions and H3O plus. That H3O plus means that the reaction is going to produce something acidic. So if we were to start with 0.1 molar HNO2 and let this reach equilibrium, we would notice that at equilibrium, we still have a fair amount of HNO2 remaining in solution and only a little tiny bit of products. So this is what a lot of weak acids look like. There are different strengths of weak acids, so sometimes there would be some more products and some less reactants, but overall there still will be some of each of those in solution at the same time. So that's all I have for this section. And remember, if you need to go back to your general chemistry notes, you can do that because a lot of this is very similar to that. And again, the worksheets, I've worked out a couple of examples and I think it's pretty clear how they work, and they should jog your memory because you have done this stuff before. But as usual, if you have any questions, feel free to ask and I'll be happy to help.